I can also tell you that a few years back, I've been in, I also participated in a Google Accelerator. So I have some background of entrepreneurship, and I can definitely understand all the things that you probably are going through in the last couple of months, taking some idea and making plans to execute it and build a company. So this is really cool of you, and I'm really happy to be here. So let's get started. So what are we going to do today? What do I have for you? So I'm going to give you some background about IoT. I know that most of you are engineers and you know that, and you have some background, but I want to state the obvious and also give some definitions. I'll try to do it short. And then I want to say a few words about deep learning on the edge, that currently a lot of IoT systems are not, I guess, not using already, because it's maybe sounds a bit complicated or even an overkill technology for a lot of IoT systems. But I think just to get to know what is out there maybe could be good for you, like for the future. So we'll just say a few words about it. And then I try to summarize, and I'm also going to give you the presentation of all the bullets and points of things that I learned when I was working in the IoT industry, which was for a few years. And just to give you some things that I learned that maybe you can have like as a checklist of what is relevant for your system, and to take decisions when you're thinking about all kinds of possible things that the entire system can have. And also just to talk about the different architectures and how you can connect devices, what kind of devices, what abilities each device have. I hope we can like make the most of it in the next like 30 minutes that we have. So let's just begin with the definitions. What is IoT? IoT is the Internet of Things, literally a network of devices that are connected to the cloud. It's just an IoT device is an IoT that has some connection. It means that we're taking machines, heavy machinery, things that never used to have connectivity, and we're going to connect it to the internet. It also means a physical network that now is being deployed with specific technologies that are relevant to IoT. We'll say a bit about it later. Not necessarily in your area, you have it already, but it's something that the world is going towards. And usually, why would we want to connect devices to IoT, like to the internet? Why would we want them to be smart? We usually would like to gather information from different sensors. We may want to control things from distance. And when we're going to have all this information in the cloud, we can do smarter things with this information. So the world of IoT, if we'll take it a step backward, before we had internet, it was just like embedded systems. Embedded systems mean any device that you just had a microcontroller, some kind of compute power in it, and you could do smarter things. Now, embedded systems can be very, very smart. It could be your coffee machine. It could be like your digital camera. It can be so many things. It could be like entire cars and airplane systems. But when you take a device, even if it's really small, and you connect it to the internet, it turns out from an embedded system or a smart system to an IoT device. So now in the IoT, like in the world of IoT, we have from one side devices we need to define and prototype and make them work. And usually they usually have at least sensors, like they not always have actuators. Sensors just means that they have different ways of detecting the environment around them, so they can learn something about the environment. And some devices only have sensors and they only gather information. Like you can look at it as like a read-only mode, what's in the environment. But like others can also have actuators, which means that they can do something in the world. They can influence the world in some sense. Sorry. So this is the devices on one side, and we would like to have some way to take all this information and also access to the devices to the cloud. And usually in the cloud, we're going to be monitoring the devices from a distance, monitoring the information that we collect now and that we have from, it could be years and years from now. If you're going to start a system now, we can have some smart analytics. And in some architectures, which depends on what you are defining to your own device, maybe you can also control back the system or parts of the system and then control the devices from afar. So in order to do that, in order to add the internet to the devices, we have different wireless communications that will connect us to the that will connect the devices to the cloud. And I think like the most basic one that everyone recognizes with IoT devices is BLE, which is Bluetooth Low Energy. Bluetooth Low Energy is not Bluetooth. Bluetooth needs more power consumption. Bluetooth can have a bigger bandwidth. Bluetooth Low Energy is some protocol that was introduced as part of the standard. I think it was 4.2. But don't get me wrong if I'm not correct about the version, but it's like a lighter version of Bluetooth. It's Bluetooth Low Energy, and it's supposed to last for longer on the devices. And usually most of the IoT devices will have a Bluetooth Low Energy on them. Also, probably like regular mobile phones today already have Bluetooth Low Energy and not just Bluetooth for like at least a few years now. So one way that a device could be connected into the internet is to have a Bluetooth Low Energy, but this is a very local range of wireless communication. So it means that it can talk in some range, but it needs someone to send it all the way to the cloud. So usually if a device only have Bluetooth Low Energy, it will have to talk to some gateway. It can be a mobile phone, it could be a device that you designed just to be a gateway that will have Bluetooth Low Energy, and they can communicate and pass all the data from one to the other. And then the gateway itself could be a gateway to the internet, either by a regular cellular connection or with Wi-Fi, some way to take these less smart devices and move them all the way to the internet. You can also, and I guess this will be like the cheapest device you can design. That is an IoT device. Now you can put some other chip on it, like Wi-Fi. We'll see a few boards later on if you're curious already right now. You can have an IoT device that has Wi-Fi on it, and then the device itself can talk all the way with the cloud. Because again, you're going to have some access point somewhere, right? You need to have internet connection with Wi-Fi in the area, but then that's also one option. The third option is to have cellular devices. And I think that in the last years, there are many devices like that, and they're getting cheaper and cheaper. And this is what I talked about before when I said that it's actually a physical internet, the Internet of Things, because they are like one of the examples for what is called low power wide area network. Wide area means that the small devices can go all the way to the cloud. And like one of them is narrowband IoT, which is a standard that is now being deployed in different areas of the world just for these devices. It literally means that we have our cellular connections like LTE and all, the high bandwidth connection that we use with our smartphones all day, but the devices has different type of connectivity, and it's literally an Internet of Things. So as we just saw, there are a few different designs that we can have, and the device will be, I don't know, smarter or stronger or whatever you want to call it, depending on what connectivity you're going to give it. So as we said before, these devices probably have sensors. Some of them have actuators, which mean they can do something in the world, turn something on or off, change something in the environment. And also they need some kind of means. They need a mean to transform the data to the internet. And it could also be, you can design it to be only in one way, as we said before, but you can also design a system that is two ways. And then you can also have control from the cloud to the devices. So this is really like the definition of IoT in a nutshell. Now, this is an example that I sometimes use when people are prototyping with Arduino, because Arduino, if you know, it's a company, and it's also a community of a lot of makers. I know that a lot of your engineers and are very well, know very well this field of prototyping and creating the devices themselves. But it could be a really good way to prototype with Arduino, because there's a big community. There are a lot of examples here. I just have a link of one of them, but you can literally have so many sensors that it's easy, and there are available examples online how you read from the sensors, what are the range, what is the specification for each and every sensor, because you can have the same sensor, but like cheaper ones maybe will be with like less sensitivity, but if you invest more money, maybe you'll be more accurate. It really depends on, do you need the device to be cheaper, or do you need the device to be more sensitive? So it's true about different types of sensors. Obviously, in the realm that you are working in, things like humidity and temperature, and maybe to detect daylight, or maybe to detect smoke, or maybe to detect movements, are things that could be relevant for you. And I think the easiest part is to choose a sensor and to make it work. But like the harder part is to understand the product and the needs, and what is it that you actually need, and what are the things that you really need to learn. And I'll give you an example that I think is interesting in this case. Like you can have a device that maybe is near something that you grow, and you can detect temperature. So is it really interesting to know what the temperature is? So, you know, you can say, yeah, it probably is, and you can detect it and send it to the cloud and all that, and that's great. But the question is, what is it that we learn? Like, do we just learn the weather and the temperature, or something that we can maybe know if we'll just open Google and search for what's going to be the temperature at the same place? And maybe then we're going to figure out that we have this like graph of like, you know, in the morning, it's not as warm. And then later on the day, it's getting warmer, and the temperature is in this and that range, things that you already know. So maybe it's not interesting. Maybe it's not something that you need to know. But if you take the same sensor and you transmit the same data from different places in your field, and then compare them in the cloud, maybe then you can learn that you have slight differences that maybe makes a difference. I don't know, maybe you can turn on some machinery in this and that cases. Like, it's not just about what we are sensing, it's also about in what way is it valuable for us? What can we do with it? Do we only sense things that are trivial, or do we actually sense something that is relevant and important for our specific product and the entire system? Okay, so we know a bit about sensors also. And I wanted to give you a few examples of like prototyping boards that you can work with. And just like we said before, it contains of some microcontroller, right? And also some communication means. So there are a lot of things that are already standard, like you can buy this is like Nordic semiconductors have a lot of information online about technology. They have great forums for questions. Also, Arduino is the same. Adafruit is the same. The ESP board is widely used. These are like devices that I think a lot of people are using, and due to that, you have a lot of information that, in a way, the technical part is already solved. Like maybe I guess the first time you build some system, it looks like scary, and you maybe don't know what to do. But then eventually, when you start looking online and connecting things and look at examples, you see that a lot of the technology part of it is, in a way, it's a solved problem. It's a solved issue, because you can find the answers. You can understand exactly how to read from each and every sensor, and you need to think more about things that are relevant for your own product. Like, I'll give you an example a bit later. Let's just go over a bit the boards. So what you see here is that you already have a few boards that, in a way, the drivers that are related to how to use the cellular network, or you see there's a different type of technologies that are related to IoT, like there's the narrowband IoT, or the LTE Cat-M, Cat-M1. You see that they support both. The ESP uses Bluetooth. This is regular Bluetooth and Bluetooth Low Energy, but also like Wi-Fi. You can have devices only with Bluetooth, like with a smaller range. So you have a lot of options how to design your devices, and you need to decide. And I'll give you a cheat sheet with all the bullets of what to take into considerations. But you need to understand what's in your system, and then I guess to implement the minimal things that you need to have in the device, because it's huge systems. Usually it really depends on what, but like you would want to just to pay the money that you want for the information that you want and for the communication systems that you need. So prototyping these type of systems is basically to understand the needs, to choose the board with all the things you need, to choose the sensors, and to start working with them. And again, IoT systems are, I think, I don't know if like product-wise, it's true to say that they are in wide use, but I know that a lot of the tech things are already solved, and you can look for things online, and it will be, I think, less frightening than just, writing something the first time. So we talked about like the most basic devices. I'm going to spend just a little time to say a few things about deep learning. I know that it's not relevant for most of your startups right now, but I think that it's just good to sometimes be open-minded about things that maybe you will be able to do in the future. So I just want to go over it really, really brief. The world of deep neural networks, like what they call DNN or deep learning, are usually the world of gathering a lot of data. Let's say that in a year from now, you're going to have a lot of information about your system, and usually predicting something or learning something or recognizing some pattern or having some input that maybe you couldn't really do with a range of if and else's in like traditional code. And deep learning world has two stages. The first one is that you take all the information and you train a model to do something. Let's say, like one of the most basic examples they give is like to take a picture and to recognize if you see a cat or a dog, or to recognize something. It could be to recognize a plant. It could be to recognize if the plant has some like disease on it, like a ill or healthy plant. So the first part is just to understand what information you have, to understand what are the tools that what are the networks that already exist today that you can maybe utilize to solve your own problem, and to train a network to do that. This is something that you usually need like high power machinery. You will do it in the cloud. But then when you have already trained model, you have the inference phase, and this can be on small devices. And today you could also deploy it on like on microcontrollers, and I'll show you that in a bit. And then you can just do the prediction that you need, or the problem you need to solve, after you already have a trained model that knows how to recognize it or know how to answer the question that you had. And this you can do on your mobile phones, like smartphones, and you could do it on microcontrollers, and I'll show you a few in a bit. The world of neural networks is a world of a lot of frameworks, things that are by Google or by Facebook, and a lot of different frameworks that you can train your model on. And afterwards, you can also deploy them on different devices, like different hardwares, very small inference edge devices, or really big accelerators that are really just designed for that. But when we go to the world of IoT and of microcontrollers, what is in a lot of use right now is just TensorFlow Lite, which take the models and do this process of deploying them on very small devices. And it can really focus you. There's also a big community named TinyML, and there are books about it that like, it makes the world much, much simpler because the devices are small and the needs are a bit more minor. And just so you can have a feeling of what are the things deep learning already solved today. And maybe you can think about in the future, when I have a lot of data, or when I know my customers in depth, maybe I can think about what problems we can solve for them using deep learning. So today, deep learning do pretty well. I'm sure these are things that I found online and things that I'm familiar with, but like, I'm sure you can go online and search for more things, but like some of them are like sound recognition, speech recognitions, detecting different types of outliers. Let's say you have a lot of information about payments, and you can detect that something is wrong because the model knows the normal state, and now it can detect when something is going wrong. Things that you see when you go online is recommendation systems, like when you read something and you like it, and then you can give things that are suited to the things you like. They learn patterns, and they can, in a way, it's a problem of of like having like buckets of similar things. Like if you like this thing, you probably like some other things. Also a lot of image recognitions, like recognizing things inside pictures. There's this field is really, really developed for computer vision. And different types of classification problems. Classification problems means that you have a set of data that you put in, and you know this data represents X. It could be, you can have information and you know that this is information, I don't know, some text, and that's a happy text or a sad text. Something that you can tag at the end of it and say, I have a lot of information, but I can tell you this one represents something. So the network can learn these patterns, and then afterwards, when it see real data in the real world, they can say, okay, this is a sad story, this is a happy story, this is good, this is bad. So to classify things, it could also be things like, you know, this is a picture of a cat. It's also a classification problem. And in the world of image, of computer vision, you can also do some image segmentation, solve segmentation problems, like saying, in the picture, this is the plant, and this is the background or the sky. This is the part of the plant that is ill and has some disease, and the other is okay. So taking like one of the things you'll see online when you search for it is like a picture of a car, and to see this is the car and this is the background, okay? Or to take a photo and give some short description of it. So these are a bit more complex problems that maybe just from, you know, getting simple raw data of sensors, you won't be able to answer more complicated problems. But when you have a lot of data, you can maybe recognize patterns that are more relevant for you. So I just wanted to drop it here, and like I talked about a few minutes, and just to say that know that one day when your system will be better, maybe you can use the data that you have. Data has a lot of value eventually, because this is what you gather, and maybe consider at some point of time to add the data scientist to your team to see what else can we do with the data that we already gathered, even if initially this is not the reason that we gathered the data for. Okay, so I have here like a cheat sheet of what is the process of developing a deep learning project, or to do something in this area, but I don't want to get into it now. I just want to have it here. If you want to look at it later, you can. But I did wanted to show you that if you go to the TensorFlow website, you'll see that there are a lot of microcontrollers that already support deep learning, which is amazing. Like they are tiny, tiny machines that no one ever thought that they would be able to run these models, and it is supported now. So it literally things that you can implement and use, and they're not that expensive. So you have lists and you have demos for that, and you can definitely do that. And also, just to set aside, there's always the case of Raspberry Pi, which is, it's not a microcontroller, it's a single board computer, and it runs Linux and has a lot of much more power, let's say that, like compute power and all the peripherals and utilities. It's a small computer. So for some cases, maybe some of the network can be with more computational power. Okay. So now I just took some of the things that I learned during the years, and I literally listed them, so you can take a look at it afterwards, the slides, and think, you know, is this bullet good for my project or not? And just to things that I learned along the way, to try to list all of them so you can make use of them. And I'll just start going over them. I hope it's not too overwhelming, but I think it's the most practical part, because I probably until now just told you things that you already know. So when you look at the system and you design the entire system, the things you need to do in general, you need to start to define, like, you know, some of the projects need a GPS as its main sensor, but maybe others need temperature and humidity, and maybe something that I'm not aware of that you can sense because there's some hardware that can do that, okay? So the first thing to do is just to decide what are the different parts, and how do they interact? How do you take all the information and transmit it to the cloud? And I think another thing to consider is when you start building something and you have one client and you're already only thinking about him, maybe the next client to come, will you need to design a new system to help him out? Or can you beforehand design your system so it will be generic in a sense, or some of the things will be generic, so you can just configure things for a new client and not need to, you know, burn new devices or like design device from scratch. So sometimes just to bear in mind, okay, I have one project and the first client, but the one that will come afterwards, maybe I can do some design decisions now that will support my technology to be more generic and to support the future clients. So when you start designing and prototyping and thinking about these things, some of them is related to pricing. Like, are you using something that needs royalty? It could be operating systems or bootloaders or IDE that you work with that you need to pay money for. Some of the options are free and some of them are not, but that's something that it's something to take into consideration when you design a system. Also, how easy is to use the SDK or the IDE that you're using? Do you have support online for that? Or are you using some hardware that you designed from scratch, or that you're using something that someone else, you're depending on like a third party for your hardware? And then maybe if they won't be stable, or if they won't have documentation, then you will have problems. That's also something to think about. And just in general, how easy will it be to the development process, not just how the end product would be, because we're spending a lot of time training new employees and like learning new technologies and learning the hardware itself. And if you have everything available, it's much simpler and more easy to work with later on. And also there are like general guidelines that you need to think of, like designing security of the system from the beginning. Like if you're only measuring things like humidity, it's not like a secure information that you really have to worry that someone will listen to. But if you're transforming, if you want to do transactions of money, then the security needs to be in a different level. And security needs to be at all parts. Like there are already hardware for IoT that supports security, like to save passwords and stuff like that, but also take into consideration where can information leak. And you need to do it for the entire system. So these are the things that you need to think beforehand. Where are the critical parts? What is the most private information maybe I'm transferring? What do I need to protect more or less? You can also sometimes say, you know, for this component, it's not that important. Someone can listen, someone can, I don't know, have the information. It really depends on the system itself, but you do need to think about it beforehand. And also some general things like, will I need software upgrade? Like, am I deploying some small devices or maybe stupid devices in the field right now, but then 3 months from now, the mobile application that is working with it will be upgraded and maybe I won't have compatibility. So these are also things to consider. And also other things that you can participate beforehand, like anticipate the problems that you can have in troubleshooting. Maybe something you know about the environment that the IoT device is going to be located at. Like let's say you need to put something on a really high, I don't know, tree. I'm just saying. What is the installation process? If you need to replace a device, if it's raining, like what are the things that you know that since the system is not sitting in some you know, storehouse in somewhere in a reasonable way where computers should be. What are the problems that can happen? Maybe you won't have reception in some parts. Maybe, I don't know, you need to make the device to withdraw some physical conditions. And also to think beforehand about maintaining the entire network. Like if you have a really cheap device, maybe if it's wrong, do you need to collect it and just replace it with another one? And how easy will it be to replace small device with the other one? What would you need to configure? Or if it's a more more pricey device, maybe you would like to collect it and repair it. So this is really in general, but we can go a bit more into details.
I'm just jumping in really quickly to see, just because of time, to see maybe if any we want to see if anyone has any questions. If we want to pivot in that direction.
How much time do we have? Like a few more minutes?
A few more minutes, yeah.
Again, I outlined everything here, so you can use the slides afterwards, even if I'm not going to be there. So you can have the slides.
Yeah, Dafna, I think that like we can be flexible on time, but maybe it's worth at this point in time also finding out if anybody has questions, and they can, if they do, or if they want you to speak about something specific, they can either like say it or they can write it in chat. So anybody who's on the call who wants Dafna to speak about something specific or would like to ask her about something specific, then
I can just show you what I'm going to talk about in the next slides, and maybe it will also answer some questions. Is that okay?
Yeah, no, but you can also, like, people can write in the chat if they have questions, and you can just go on. Like we have enough time so that you can finish up. You shouldn't feel rushed.
Okay, thanks.
Okay.
So shall I continue or wait for questions now?
I'd say that if people want to ask a question, they can write it in the chat for the moment.
Okay.
And we'll let you. Okay.
Sure. Thanks.
Okay.
Okay. So this was just like the general things that I thought about, but now let's go into details. Like, how exactly do you start and create an IoT system? So the first thing you need to do, as we said, we need to define the devices and start creating them and implementing them. Okay. So the first thing is the hardware. And as I said before, the first thing you need to do is what is the physical conditions that it needs to take, because maybe you're connecting some sensors that will not withstand the max temperatures. I don't know. Each and every device have specification, and you can see in the spec things like the conditions that it can or cannot withstand. And the second thing is what type of device it is. Is it a small one and very simple, like just to collect a few things? What is the compute power that you need, which means what microcontroller you're going to choose? Would it be a very small 8-bit microcontroller or something more powerful? There are already really good devices that are pretty cheap, but you do need to think about how much memory does it have, how many input and output pins it has, so you can connect all of your sensors and what types of them, because some sensors need like PWM and some of them just need regular GPIOs. You need to have the list of it and like go into details. So can I connect all the things that I want to that specific microcontroller? And also, do you need any additional storage? Because maybe you want to define a device, like to prototype a device that it's going to wait a long time, and once in a while someone's going to come with his mobile phone and pick up the data. So maybe you need more storage so you can store all the raw data from all the different sensors that you have. So you need to do the calculations, like I'm going to be measuring from the sensors once a day, twice a day, once an hour, I don't know, and I have this and that many sensors, and each of them needs this and that bytes, and I'm going to collect the data once in a week. So you need to calculate exactly that you have all the space you need in the device, so we won't lose information. And also, do you need some peripherals like real-time clock? Do you need to, I don't know, do you need to just send something and maybe turn something on and off? Or do you really want to know what is the time right now so you can attach that to the cloud? There are many options for that, but you need to decide exactly what they are. And as we said, like in the beginning, we kind of talked about it a lot. How will it be connected to the cloud? With what technology and in what way? And specifically, what is the sensors that you need? As we said before, for some sensors, you can get some of them like cheaper or more pricey, and you want to optimize how sensitive they should be and versus how much they're going to cost, depending on your needs. And also to define what are the actuators that it has. Can it turn on something on and off? Can it, I don't know, has some thing that it controls, or it only senses things? And after you have all that, you also need to know what is the power consumption for the entire thing, and what battery you're going to use and how much time it's going to last. Because you won't be able to deploy a complete system with a lot of devices and every week come and replace the batteries, right? Like, it doesn't make any sense. So you need to consider things like sleep mode of the device. Maybe most of the time it could be turned off, and only once in a while it will be turned on. Or maybe if, I don't know, if it senses something, it can have some interrupt, and then it will be turned on. You need to calculate these things beforehand, because otherwise the devices you won't be able to utilize them if they run out of batteries. And also, if they're like smarter devices, if you need something more complicated, maybe you want to have some software upgrades in the field, or maybe not. Maybe you just want to come and replace the device itself. It really depends on what it is that you need. And in some cases, when the devices are a bit more complicated, maybe you want to have some information that you can gather to the cloud in two ways, or not to the cloud, maybe to store it locally about crashes or problems that you have, and then to go and collect this information for your own debugging and understanding of the system. So all of that was hardware issues. And software-wise, there are two options that you can have. So, sorry, you need. I'm going to talk about the software part of the. I'm going to talk about three different parts of the software. One of them is the edge device itself, and then you need to talk about the cloud and mobile consideration. So the most basic things that we just talked about is you define some device, you need to support all the hardware abilities, like drivers, and see that things are working, like sanity, see that what you actually have on the hardware is supported by software. And then you need to define and implement what is the device routine, like what will it detect once in how many times, if something happens, do we define it as an important event? What information does it store? Does it need to calculate something? What is the actual business logic of your specific device? And also to handle cloud connectivity. You can send things in, there are a few protocols that are in the IoT industry that people use, like MQTT, you can read on it online, but you can also define protocols that are yours, and you decide exactly what it is that you're sending and in what order and what does each and every byte means, but you need to define that and implement that. And you need to think about cases where you're not going to have reception and there's no connectivity and something happens. Do you want to store something on the device? Do you want to lose this information? Do you want to do something with it? It may happen in IoT devices. And also to think about some relevant cases, as we said before, that you can configure the device. So maybe one client can get some configuration and other client can get different configurations, or configuration could be maybe the client can define in what time it's going to sample the sensors, or in what threshold will it turn on some alarm, I don't know, something like that. So some of the things are configurable, and you also need to be able to support it in a configurable way. Probably when someone comes to install the machine, it will also configure this information. And also, as we said before, compatibility issues, like you sometimes need to think about future releases. So you can, to begin with, send that this is your first release and I can support this and that features. All kinds of compatibility issues. So this was relating, like really just a general checklist of things that are related to the device, but also you need, right, like what the devices are doing, like they're detecting things, maybe they can take actions from some threshold, some simple calculations, something like that. But then in the cloud, and sometimes you do operations on the mobile system, sometimes you only display things to the mobile, but like there is more compute power not on the edge side. So you need to collect the information. If you need to control things, how do you define these things? How do you control things and worry about security so no one can abuse the system and control things for you that you don't want them to hack and control, things that you want to calculate, and obviously eventually also to report about what the system is doing, and maybe to output reports that you can get the money for, like you can show that the system did this and that, it uses this and that bandwidth, and this is the pricing that you're going to take for the system. So I think like a really edge case that I thought about that maybe is, it's not that important, but it's interesting, is just to have in mind that a logical device is not necessarily a physical one, because maybe you want to detect a tree, I'm just saying, okay? And the tree is going to stay there, but that's a logical device. Like you want to represent this tree. But then if the physical hardware is now that has some specific MAC address is having some problem and you want to replace it, you would want in the cloud to still know that it's the same tree, even if you just replace the specific device that just got broken. Okay, so sometimes we need to, like, not sometimes, we need to plan ahead that maybe we have some logical definition of a device, but the technical physical device that is connected to it. Was that a question before? Someone opened the mic? Okay, I'll continue and give you a few more time. I see that I'm really running out of time. Okay, so also in the more complicated part, the mobile and the cloud, you sometimes would like to define permissions. Like maybe you can control the network and you wouldn't want everyone to control the network, right? Or maybe you want the developers to have some abilities that the clients won't have. So thinking about permissions and different users of the system is also something that you need. And also simple stuff, like not all the categories are of the same significance, but like how do you register a device to the system? Can you just turn it on and it will start working and it will start transmitting to the cloud and it will be like seamless and register itself? Or do you need someone to physically come and configure something and maybe register something with a mobile phone or without a mobile phone? You need to think about how do you register devices into your system, especially in systems that you have a lot of devices. It's not necessarily every IoT system is has a lot of devices. You can have a few and they can be more expensive or less expensive, but sometimes you have a lot of devices and you need to register them in an easy way that you can maintain. And again, just after you did all this big effort and you have all this information, what reports can you generate? Do you want to compare between devices? Do you want to take the same device and compare it with different days of the month of different usages? Do you need algorithms that will run over in the cloud? Like maybe you can have, I don't know, small sensors, but you want to run some complex computation. It doesn't have to be deep learning things. It can be just something smarter that the edge device itself can't run. And also, like, is remote control is relevant for the system? For what devices? For all of them? For some of them? How will it work? What commands can you give? And I think this is something we talked about before. Can you maybe mute that? Thanks. Okay, so I see that I'm running out of time. I'm just going to leave you that. But just to say that sometimes you would like to do the calculation at the edge part and sometimes on the cloud. And there are different considerations why to do each. So this slide is kind of self-explanatory because I really try to output everything I can. But like sometimes from security reasons or privacy reasons, you would like to do the computation on the devices, but sometimes you won't be able to because there's I don't know, you don't have enough compute power and the algorithm is very sophisticated. And so like there's different considerations like here and there, and you need to think about your own system and what is relevant for you and for what calculations. So I think basically we are like here at the end. I really tried.
Really quickly, Isaac,